So in problem number 12, I believe that students, and I understand, have a very difficult time with problems that aren't just give me a number answer. And especially when you have variables and have to deal with variables instead of numbers. The biggest thing to do is to think about how you would solve that problem if there were numbers. So for instance, in this problem we have a circle and we have a square. And basically half of the circle is inside the square. We want to find the probability of finding a number not, or a point, sorry, not in the circle. So basically we want the area of this red sector compared to the area of the total square. And so since we don't have numbers, we would find areas if you had numbers. So for instance, to get the area of the square, you would multiply 2r times 2r, that's 4r squared. That's the area of the square. Then to find the area of the red space, you would take the area of the square, again 4r radius squared, and subtract from that 1/2 of pi radius squared, because the radius here is just r, radius squared would be r squared, times pi 1/2. So you get this, you set that up, the area of the square minus 1/2 of the area of the circle divided by the area of the square. When you actually set this up, you can see that now, still not sure what to do, but some things cancel out here. All of these terms have a radius squared. So you can cancel those out. And now you have 4 minus 1/2 pi over 4. Well, you know you can't have a fraction in a fraction, but you can clear the fraction by multiplying all three terms by 2. So 2 times 4 is 8. Minus 2 times 1/2 is 1 pi, so that's 8 minus pi, and 2 times 4 is 8. So 8 minus pi divided by 8. In the simplest radical form, that is the correct answer. For problem 13, use Euler's theorem to calculate how many faces of a polyhedra has if it has 30 edges and 12 vertices. So you'll remember that Euler's theorem is faces plus vertices equals edges plus 2. So we've just plugged in numbers here. We want to solve for f. 12 goes in for the vertices, 30 for the edges plus 2. So 30 plus 2 is 32. The number of faces plus 12 has to equal 32. You would subtract 12 from both sides and get that the total number of faces in the polyhedra is 20. For number 14, we have a concrete block that has a cylindrical hole drilled through it. Once the hole is drilled through, they want to know the remaining feet of concrete left in the block. So first you have to find the original volume of the concrete block. It's a cube, 6 feet in each dimension. So 6 times 6 times 6 is 216. And that's the volume of the cube. Now you're going to subtract the volume of the cylinder. We have a typo there. Cylinder. And volume equals pi times the radius squared times the height. Really the area of the base. So to find the area of this circular base, the radius would be 2. 2 squared is 4. Realize we're not using this 4. We're using 2 squared is 4. Times the area, times 3.14, because they told me to use 3.14 as an approximation for pi, times the height when you do of the cylinder. When you do all that, you get 75.36. So 216 for the total volume of the cube, subtracting 75.36 for the volume of the cylinder, gives you a volume left of 140.64 cubic feet. For number 15, we need to find the volume of this right cone. And in order to find the volume, we need the radius of the base and we also need the height, which they don't give us, but they give us that this angle is 34 degrees. So using trigonometry, we need to find the side adjacent to the 34-degree angle, and we have the side length opposite, which is 2. So tangent equals opposite of 2 over adjacent. So in our calculators, when we actually do, and I'm doing this, 34 tangent equals 2.9651219, blah, 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 blah. So when we take that, multiply it by the radius squared, which is 2, times pi, we're using a pi button, and divide by 3. So once again, if I was defining the area of the base, that would be 4 times the pi button is going to give me 12.56637, blah, 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 times the height of 2.9651, that equals 37.26, but now I have to divide that by 3, and that's where I get the 12.42. For number 16, you are finding the volume of a satellite that is made up of a cylinder and 2 hemispheres. The hemispheres have the same radius as the cylinder, and they fit snugly on either end of the cylinder. So basically you have 2 hemispheres making up a whole sphere and a cylinder. So your volume for this sphere is 4/3 pi radius cubed. So 4/3 times pi times radius cubed. And they want the answer to be in terms of pi. So that means you're going to do 4.5 times 4.5 times 4.5. That's 91.125 times 4, and then divide that by 3. And you get 121.5 pi for the volume of the sphere. For the volume of the cylinder, you're going to take the area of the base, which is 4.5 squared, which is 20.25, and it's going to be 20.25 pi, because you're leaving this in terms of pi, and multiplying by 19. So you get 384.75 pi. When you add those two together, you get 506.25 pi. So your answer is looking like 506.25. This is really messy, obviously. don't have a slate here at home tonight. Pi. Okay? For the next problem, you're converting 25 degrees to radians. And the problem after that is radians to degrees. So when you're converting from degrees to radians, you're multiplying by 2 pi over 360. And when you convert from radians to degrees, you're multiplying by 360 over 2 pi. Let's see, you can see that line there. So for number 15, 25 times 2 pi is 50 pi over 360. The zeros cancel out, and your answer would be 5 pi over 36. For converting from radians to degrees, you can just multiply that if you want to. Remember, you're leaving it, remember here, the pi on top and the pi on bottom cancel out. So 360 times 17 is 6,120 divided by 20. So the answer is 306. For number 19, you're finding the density of a block of gold. You have to remember the formula for density is mass over volume. This is pretty easy if you remember the formula. 9,660 divided by 0.5, which is your volume, is 19,320 for your density. And for the last problem, number 20, this is a right triangle. When you rotate it, you're going to have a cone.